Good morning. What would you think if I said to you that the fastest way that we'll get vehicle manufacturers to provide clean, efficient vehicles to us would be for us to radically change the way that we think about vehicles? I've spent over 20 years in the automotive industry, and it's given me a front row seat on what's really a three-way dialogue between the push of technology development from the vehicle manufacturers, the pull of our market demand, and the guiding hand of regulatory oversight. Now, cars are everywhere, and they perform multiple roles in our lives, from being functional, common appliances through to offering status and lifestyle statements. And because we have these strong emotive ties to what's actually a machine, I think that we sometimes forget what cars actually are. So cars are highly complex machines, and they have to operate in a wide range of areas. They have multiple safety-critical systems. They have to operate for a long period of time, and they have to operate in every conceivable weather condition, from the Arctic Circle to the Australian outback. And on top of that, they have to do that with differing levels of build quality, with inconsistent maintenance. They have to do it in what's actually an almost uncontrolled operating environment, and do it with operators who are minimally trained. And for some strange reason, many of these minimally trained operators think that they're brilliant drivers. Now, I don't think there's any other machine that we interact with, let alone so frequently, that we could describe in the same terms. Would you lie down in an MRI scanner if I described it like that? So we are the market demand, and I think it's our thinking that puts limitations on how vehicles are engineered. 90% of all car journeys are single-occupant commutes of less than 40 kilometers. And yet, because we own the vehicle, we also expect that that same commuting machine can once a year be loaded up with luggage and with kids and the dog and with granny, and travel at high speed in a baking hot summer on a German autobahn before traveling over the Alps with a caravan. Now, that's not an invented scenario. Grossglockner is a mountain alpine pass in the Austrian Alps. It's 2,500 meters high. And in vehicle prototype development, the Grossglockner caravan tow test is one of the most arduous simulations the cars have to be engineered for. So now let's do a thought experiment. Let's imagine that cars are not engineered for that extreme niche use, but instead they're engineered for that common 90%. So the cars would be considerably smaller. They wouldn't need the same power, they wouldn't need the same torque. The electric batteries would be much smaller because they wouldn't need to offer the same range, and we could charge them much more quickly, which in turn would put far less demands on the national grid. And because the vehicle is lighter, we would actually get more range back from that battery. So it becomes an engineering virtuous circle. The cars would look very different to what they look today, but they'd be engineered far more effectively and efficiently. So at Hibra Design, we're taking that thinking and we're applying it to industrial vehicles. In Ireland, there are 600,000 commercial and industrial vehicles, and the operators spend over 3.2 billion euros in fuel costs every year, whilst emitting over 6 million tons of CO2. So the operators are being squeezed between exponentially rising fuel costs and ever-increasing amounts of emission legislation. But there are very few clean technology alternatives available for the manufacturers. And that's because there's no regulatory mandate to say that industrial vehicles have to move to electric powertrain by a certain year, as there is with road cars. So that means that the manufacturers just don't have the same push to develop that technology. And the reason there's no regulatory mandate is because the governments know that there's no silver bullet for the electrification of vehicles. You could take a diesel truck today and drive it from Cork to Dublin, and then tomorrow you could take that same truck and drive it Cork to Dubrovnik. Same truck, same technology, same solution. But that doesn't exist for an electric version. Now, how about instead of trying to engineer that diesel truck into an electric version of itself, we were to engineer vehicles with the specific operational requirements in mind? So at Hibra Design, we're focused on the off-highway industrial vehicles. These are like quarrying trucks or airport refueling trucks, or even the tractors that are helping to re-wet the bogs. So all of these vehicles operate over a short range, and they're depot-based. But more importantly, it's a quantifiable, known, and predictable duty cycle. And that means we can engineer specific solutions for it. It's not the Cork to Dubrovnik problem. It's not this, or we know day on day, year on year what they're doing, so we can engineer specific solutions for them. Now, we know we're not going to get a solution for every type of vehicle, but we do believe that this is the fastest way to get to a national fleet average reduction of emissions. So at Hibra, we talk about our solution being vehicle agnostic and operational specific. So now, what does operational specific mean if we go back to road cars? Well, very simply, it just means the journeys that you take. So I'll leave you with this. The next time you're thinking of changing your car, don't think about what car you need to purchase to do all of the potential journeys you might ever want to do. But instead, just think of your car as merely being one part of a suite of mobility options that are available to you. And then think about which of those options most effectively and most efficiently will get you to your destination. Thanks very much.